Well, hello there. Welcome to this short, hopefully short little video on dot products. I've got to admit I'm making this kind of quickly because I know my students are doing an assignment that they may want to look at this. I'm going to try to get it on my website soon. You may be looking at this and not a student of mine and might go a little fast for you, but hopefully at least get you started on the idea of a dot product. I'm not going to go into the theory behind necessarily why we use dot products or anything, but just show you how to do the mechanics of taking a dot product. It is a form of vector multiplication. There's actually two different ways to multiply vectors. One is called a dot product, the other is called a cross product. And when you first learn to multiply, they let you use any symbol you wanted to, dots and crosses and parentheses, and sometimes no symbol at all meant multiplication. But here we have to be very careful, so that's why I've used a dot in my multiplication. So what we're going to do first is an example where I give you the magnitude and direction of two different vectors, and I have you dot them together. And the way you do this is you take the magnitude of A. When I put that in little bars like that, that means just the magnitude. That's your 5 meters. And then you multiply it by the magnitude of B. And then you multiply it by the cosine of the angle in between those two vectors. So it might help to draw them. You probably don't need that in this situation, but if you draw them, make sure they're tail to tail. Students that are used to dealing with vectors, they want to add them because most students know how to add vectors. Don't put them head to tail, put them tail to tail. So 160 degrees points somewhat up like that. 225 is roughly down like that. And so this angle in between there is 65 degrees. That's just the difference between these two. So in this case, A dot B is 5 meters times 4 newtons times the cosine of 65 degrees. And I did that earlier, and my calculator gave me 8.45. Now your answer to a dot product is sometimes called a scalar product because it is not going to be a vector. There's no direction to this. So we call it 8.45 Newton meters. In our unit on work, that we would call this a joule. So 8.45 joules. And that's it for the answer. Okay. Now I'm going to show you another way to do a dot product, and that is if we start with something in unit vector form. So let me get my unit vector set up, and then I'll show you how that's done. So I thought what might make this interesting is to take the same two vectors and put them into their unit vector form and show you how we would get the same product, 8.45 joules, by doing it without the magnitude and the direction. So here they are. I just rewrote them. And so if you have it in unit vector form, now you certainly could just recombine these and figure out that they're equivalent to those and then do that, but you're kind of working in circles if you do that. So instead, what you can do is multiply the like components together for all two components, or three if you have a three-dimensional vector, and then sum together all those products. So in this case, we only have the x and the y components, so we would write it this way for our problem. So it's the product of each of the components, ax times bx, and then you do that for all the pairs of components that you have, ay and by, and if you had a three-dimensional vector, you'd have az and bz, and then when you're done multiplying, you just add them together. So just to show you that we get the right thing here, this is going to be negative 4.7 meters times negative 2.83 newtons plus, and then the product of these two, positive 1.7 meters times negative 2.83 newtons. Just so happened I chose 225 degrees, which was down at 45 degrees. That's why these two components are identical. And if you put this into your calculator, I'm gonna pause this while I do that, just so you don't have to watch. So I'm just showing you my calculator display, and of course I've got a little rounding going on in my components, but I do indeed get 8.46 and the same units, joules. So that is A dotted with B. Sometimes this is you have to use both of these together because they'll ask you for the angle. So if you don't know the angle, now you could figure it out, but a quick way is to, if you have the components, figure out what the dot product is, and then take that dot product and put it back up into here and solve for the angle. So I think you might see a problem like that occasionally. So maybe you're taking a math class, maybe you're taking a physics class, but in either case, that's how you do dot products in the most usual fashion. Hope that helped. Bye-bye.